All right, so we've got a GIF here that they call this a series circuit, and it's pretty good because it gives you an idea of how you can visualize a series circuit. So if we imagine that, like right here is a charge coming out of the battery, all right, you can see that. Remember, we're talking that everything's going to come out of the positive side. That's why they're showing the positive charges, and as it comes out of the battery, it's increasing its voltage. So the height of the I don't even know, the level that it's riding on would essentially be like the voltage. Does that make sense? So it's the amount of push they have. And so it comes up, and whatever the voltage may be, and it rides along in the circuit until it gets to a resistor or a light bulb, something that's using it, right? And in this case, it's a 30 ohm resistor. And you can see that as the charges move through it, they're getting a little more spaced out. You know what I mean? So because there's greater resistance in this 30 ohm resistor or light bulb, the charges are getting spaced out because it's harder to get through. And then when it gets through, you'll see that as they use the voltage to push it through, right, to get it through this resistor, the level of voltage that you have available to you drops. Does that make sense? And then it's at this new lower voltage. And then when you get to the 10 ohm resistor, that's when you can see that they don't get spaced out as much and they kind of flip through pretty easily. And by this point, whatever voltage you started with here and it raised up, it goes down to 0. Okay? This is also pretty good because when you're talking about the characteristics of a series circuit, because you can see that, remember that in a series circuit, every resistor, every light bulb gets the same current. You remember that? Okay, so you can see here that every charge has to go through every resistance, every bit of resistance that we have. So it perfectly shows that. Okay, but you also see that the sum of the voltages, the total voltage that you get, that you start with over here, is the sum of the individuals. So you get some here that gets used, but then you lose some of it, so whatever's left over is what this guy uses after that. Okay? Now if we look at a parallel one, oops, that's not what I wanted to do. In a parallel one, we have this branch. Okay? And again, same thing. This is where our charge gets ramped up to its whatever the voltage is of the power source. Okay? I'll get the door. And it comes through and it rides along that initial wire that before it gets to its junction, right? And this is where our junction would be for a parallel circuit, where some would go this way, some will go that way. Gets through here, we've got a 30 ohm resistor on this side, we've got the 10 ohm resistor on this side. So again, you can see the higher resistance, there's a greater spacing compared to this one, or it's harder, it takes longer to get through this resistor than it is this resistor, and it kind of looks like this one's traveling more slowly. It's hard to see, but it looks like it's traveling more slowly than this one. Now again, thinking about the characteristics of a parallel circuit where we know that everyone gets the same voltage, you see that when we get to the junction, they're still at the same heights, the same levels. But as we go through, we also know that the total current that we start with gets split at that junction between the two places, so they get different amounts of current. And you can see that we have different amounts of charge going through each resistor as it comes together. Okay? And because you have a higher resistance, you're going to have less current going through there. Lower resistance, we have more. That's why we have more of those charges flipping through. Okay? Does that make sense? Right? It's pretty good. It's pretty good, cool little animation. Okay? Make sense? Yep.